Good morning, children, and welcome back to our online class of computer application. Children, we're in chapter 4, and the name of the chapter is Values and Data Types. Previous class, we have already discussed about what are the values computer or programming language require to operate. So, from that concept, one point is clear that there are various types of values computer need to operate. Maybe arithmetic values, logical value, or relational values. So today we're going to uh, discuss some more points on this chapter. Okay, that is values and data types. So first of all, let me tell you what exactly is a data types. So see, as we know that to store a value, container is required, and container in a Java is known as variable. Okay, container in a Java is known as variable. So variable, what sort of value it will store? Whether it will store a value that is number or decimal values or a letter or group of letter. So what sort of value a variable will store, that part is done by data types. Means in a short, data types tell or inform the compiler that the particular variable which we have written will store what sort of values. Okay, so that exactly is a data types. Now see here the storage concept comes now. What sort of value it will store? So wherever a storage concept comes, that means it need certain bytes. So byte is what? It's a memory unit of computer, and the smallest unit of computer is bit, 0 or 1. And 8 bit makes 1 byte. 8 bits make 1 byte. Okay, and the storage of the data types are measured in bytes. There are different bytes storage for different types of data types. So children, data types are categorized in two different types. So point number 1 is primitive data type. Primitive means inbuilt. They are predefined, pre-made. Okay, they are like a keywords for Java programming. That means you cannot change the case also. You cannot change the like letter for capital to small or small to capital. They are predefined, inbuilt. Okay, that's primitive data types. Another we have is non-primitive data type. Non-primitive means user defined. Non-primitive are also known as reference or composite data type. That means the name of this such data types, non-primitive, are given by user. Okay, so their storage are not limited. We can store how much data we need. But in case of primitive data type, their storage are limited to certain bytes. So children, understood what is data types? It tells or informs the compiler what sort of value a variable will store. Secondly, it has two parts: primitive, non-primitive data types. Primitive, inbuilt, they are the keywords. We cannot change the cases of that particular words, and they require certain storage capacity because they have the limit. Okay, and the storage are measured in bytes. Non-primitive data types, user defined. We write the names of non-primitive data types. They are also known as reference or composite data types. There doesn't limit in storage. Their storage are unlimited. How many data we want, we can store that many. So children, now let us go in brief for primitive data types. Okay, so see here. So see now for primitive data type. Primitive data type. That means inbuilt data types. Okay, these are inbuilt, predefined. So it is basically of 8 different type. So there are total 8 primitive data types. Okay, total 8 are there. Remember this one. Point number 1 is int, small letter. Uh, Let me write with the smallest one, that is byte. Byte is the smallest data unit. That means it stores only one digit of number. That's why the storage capacity is also 1 byte. That means 8 bit. Okay, 1 byte means 8 bit. Second to byte we have sort. Up to 2 digit it can store. So the capacity is also 2 byte. Okay, 2 byte capacity. That means in bit how many? 1 byte 8 bit, 2 byte 16 bit. Third, long. All are in small letter. Okay, all are in small letter. These are the keywords. You cannot change the cases. So long means it can store up to 8 byte. Okay, up to 8 byte we can store in a long. 4, int. Int means integer. Okay, it's like part of integers, and the keyword is int, int, small letter. So int can store up to 4 byte. That means maximum digit it can store is how much? 4 digit. Okay, 4 digit it can store. So this byte you can measure in digit also. Like when you are mentioning a variable as a byte, it can store only 1 digit. And if it is short, you can it can store up to 2 digit, long up to 8 digit, and int up to 4 digit. Now let us come to the part of 5. That's point number 5. Float. So float is a variable, okay, which stores the values as a decimals, like 10.5, or you can say 2.5, means any number which consists of decimal values. So here also float can store up to 4 byte, means 4 digit. Next we have is double. So double means, see, as the name says, double means 2, isn't it? Double means 2, twice. So double can store both the values, like double can store integer values also, double can store float values also. So double basically we use in such situation where division concept is there. Like for example, say a divided by b. Now the probability of getting answer is integer also as well as float also, because the value of a is 4 suppose, and b is 2. So 4 divided by 2, how much? 4 divided by 2, answer is 2, that is integer. And suppose the value of a is 5 and value of b is 2.5. That must say the probability, it depends on the value given by user. So whenever there is a division concept in a programming, okay, division concept, and the value are given by user, use double data types, because double has a capacity to store both integer as well as float, whereas byte, short, long, and int, okay, this 4, point number 1, 2, 3, 4, they have the capacity to store only integer value. That means they cannot store the decimal values. But when we talk about integer, it can be negative, it can be positive. They can store -1 as well as +1. Okay, -5 as well as +5. But this 4, they varies in their capacity of storing number of digits. 1 digit, 2 digit, 8 digit, 4 digit. Float. Float is used to store decimal values, only decimal values. Suppose you are storing 10, automatically it will turn to 10.0. Okay, so it need a point, the decimal value is required to be stored in a float data types. Double can store both integer as well as float. As the name says, double, that means twice, both. Okay, and the capacity of storing is also much higher, that is up to 8 byte. See, up to 8 byte it can store. Okay, so next to double we have Char. Char is the short form of character. Character means a single letter. It can be alphabet, it can be symbols, it can be numbers, but it will be only a single digit, single letters. And single letter will be always enclosed inside a pair of single inverted comma. Say for example, we can store here is say A, but inside a single inverted comma. Now any letter it can store, any symbols, any alphabets, any digits, but inside a single inverted comma. Okay, so this sort of value will be termed as a character, a letter. It cannot be a number or something else. So the short form as a keyword is a char, C-H-A-R, and it has a storage capacity up to 2 byte. Storage capacity up to 2 bytes. Okay, now 2 byte doesn't mean here now 2 letters you can store. Okay, this is not that. Byte doesn't fall directly in digit. Just for your knowledge, I just made that 1 byte means 1 digit it can store, and it is not that 1 byte means 1 digit only. Clear, children? So suppose 12, 1 2 2 digit, it doesn't mean that byte cannot store. Byte can store. Okay, that is storage capacity, means how much space it has. It has storage of 1 byte. Okay, it is not that storage is 1 byte means 1 digit only. Just for remembering, you can say 1 byte 1 digit, 2 byte 2 digit, like that they are storing. Okay, so char 2 byte doesn't mean that 2 letters. Now 2 letters means suppose you can give 12, no problems. 2 letters are there, but it will term that single values only, that is 12. Now point number 8. Boolean. Booleans is a such data types which store either true or false value. Okay, every electronic gadgets, they work on a Boolean part. Binary numbers, on and off. So on means true, off means false. So true means 1 and false means 0. True means 1, false means 0. That means 1 0, 1 or 0, not both together, either 1 or 0. So such type of data types, that is Boolean, it has a storage capacity of 1 bit, only a bit. Okay, it cannot go for byte. Either it can store 0 or it can store 1. So that is termed as bit, 0 or 1. It is only used to store either true or false value. So children, once again, primitive data type means inbuilt data types. How many types there are? 8. Byte, short, long, int fall in integer category. Negative, positive, both it can store, but value without decimal. These are the storage capacity. In another terms, you can say 1 byte means 1 digit, 2 byte 2 digit, 8 byte 8 digit, 4 byte 4 digit. Float, decimal values, 4 byte. Double, both int as well as float, used basically in a programming where division concept is there. Capacity 8 byte. Char, character, single letter, always enclosed inside a single inverted comma. Okay, capacity 2 bytes. Boolean, which is used to store either true value or false value. True in integer part we can say as 1, and false in integer part we can say as 0. Okay, that's why the capacity is in bit, 1 bit. So this is clear, children. Now let us move to non-primitive data type. So see, for non-primitive data type, okay, non-primitive data type. So first of all, what is non-primitive data types? Non-primitive data types are user-defined data types. That means user are defined, user are creating. Non-primitive data types are also known as reference data type or composite data type. Another name, okay, reference or composite. Now see, non-primitive, that means it is not inbuilt, we are creating. That means when we are creating, we can give random stories. That means the storage will be not limited to certain byte. It can store as many as values user can give. Okay, so non-primitive data types are many type, but as per as our syllabus in our curriculum, it has been mentioned that there are two types of non-primitive or reference or composite data types. So among that, one which we have already discussed, okay, that is class. So in the definition of class also we say class is an user defined data types. Now why we say data types? Because of the class only we create the object, and object are the variable of class. Like see here, syntax. We write class, say P1. Now this P1 is a data types, okay, which we have created based on the class. Now with these data types we can create the object also. So instead of P1 you can give your name also, class like book, pen, pencil, okay, or class Ram, Sita, Gita, whatever. But it cannot be a keywords. We cannot provide a keyword as a class name, because class name is an user defined data type. Okay, so children understood this part. Class P1, suppose, then P1 is what? It's a data type created by whom? Users, means us. Okay, now with the help of these data types we can create the variables. How? See here, P1 object new P1. Now here see one variable we have created, that is object. Again the name of object is given by us only. We can give anything, P1 pen, book, Ram, Sita, Gita, whatever, but keywords are not allowed. That means see, with the help of these data types we are creating the object. Now as I told you that for every data types it has a storage bound, isn't it, for primitive? But whatever for non-primitive, how computer or how compiler will come to know that there is no limit, and how the storage will be created automatically? So for this, there we are using one keyword, that is new. Okay, the new keyword means it is used to allocate memory space randomly in a program. That means based on the user input, what user is providing or feeding in the computer, okay, the storage capacity is created automatically. That's why we say that there is no limit, there is no bound for the storage in case of non-primitive data types. So when we are creating object, we can create as many as we want, because there is no limit. Every time when we punch, every time when we create, the new keyword will activate and it will start providing the storage space. Okay, it can create as many as our computer storage has. Depends on our computer storage, not on the data type storage. So understood children, class is what? Reference data type, because class name is given by user, and with the help of that name we can create the object or variable. So this is one example. Second example we have is array. Okay, so array is such data type which is also created by user. Okay, we create the data types, we provide the name of the data types. Now use of array is what? A single variables can be used to store multiple elements. So many elements we can store as a block. Like see here, suppose int so this is syntax. Okay, int means integer. We need to provide what sort of data type the variable will be continuing. Now after int, now the next part will be this one. This is the array, and see here also we are using the new keyword. That means the storage space randomly it will allocate, and the size we have to provide the initial storage, like maybe 100, 200, 300, 400, 500, 600, how many you want. But initial storage capacity we need to provide, user can provide. Okay, now according to this, what happens here, a is equal to, a block will be created like this, and each block will be having the index. Each block will be having the index. Now see, name is what? Single. The array name is A. That means single name with multiple index, so many position. Now we can place the value in A0, we can place the value in A1, A2, A3, A4, A5, A6, A7, A8, A9, continuation till the size what we provide. That means this is also a reference data types, because its name is given by us. This name A is given by us, we are providing, and with the help of that name we are storing the multiple elements. But there is certain limit, class only for object, array only for similar data types value. Array for similar data types value. That means here you have mentioned int, that means all the block, all the index should contain integer value only. It cannot contain integer, float, double or char, something mixed one. Not possible. That is only the limit. Class only for object, array to store multiple elements but of similar data types. So these two are the example of non-primitive data types, reference data type or composite data type. So understood, children? Data types, its type. Data type is how many type? 2 type. What are they? Primitive, non-primitive. Primitive how many type? 8 type. Non-primitive 2 types. More are there, but in our syllabus only 2 are given. Okay, children?